Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and in this video we are going to solve a gate question. So this question was asked in the year 2006 for 1 marks. So let us read this question. So the question goes like this: the process state transition diagram of an operating system is as given below. So this is the diagram that they are talking about. And then the questions ask us that which of the following must be false about the above operating system. So basically, it's a fairly simple question. There is a process state transition diagram given for a particular operating system, and we have to verify which of the following statements must be false. So let us go over these statements one by one and check whether they're true or false. So let us go over these statements one by one and check whether they're false or not. Okay. So the first option, that is option A, it is saying that it is a multi-programmed operating system. So if you see this process state transition diagram, basically this is depicting the life of a process. And if you recall, the very reason why we developed the abstraction of a process on the CPU is that we wanted to time share the CPU among the multiple programs in the computer system. So the basic assumption is that there are multiple programs in the computer system. Only then we have this need of time sharing the CPU among the multiple programs, and that is why we developed the concept of a process, right? So this statement, that is, it is a multi-programmed operating system, this is a true statement. If let's assume that there was only a single program in the computer system, then that single program can directly go and run the CPU whenever it wants, right? Then there was no need to perform time sharing and develop this abstraction of a process. So whenever you see this process state transition diagram, or whenever we talk about a process, then we are sure that we are dealing with an operating system which has multiple programs. So this statement, that is, it is a multi-programmed operating system, this is a true statement. And since the question asks that which of these statements must be false, so this option A is incorrect. So let us now discuss option D. Option B and C we will discuss together. So option D is saying that it is a multi-user operating system. So what is a multi-user operating system? So it's fairly simple. Let's say there is a computer which is being used by multiple users. Then an operating system for such a computer would be multi-user operating system, right? So for example, let's say there is a college, and in that college there is a lab which has a server which is being used by all the students in the department. So that kind of a computer has multiple users, and the operating system for that server is an example of a multi-user operating system. So we have to now verify whether this statement is false or not. So if we look at this process state transition diagram, it does not say much whether like we cannot for sure determine from this diagram whether this operating system is for a single user or multiple users. All we can say is that there will be multiple programs in the computer system, right? And as we can see, there is a ready state. So there will be multiple programs that can be in ready state. And now the thing is that these programs, either they can belong to one single user or they can belong to multiple users, but we cannot say for sure or conclude concretely from only from this process state transition diagram, right? So this statement could be either true or it could be either false. But the question is asking that which of the following must be false. So we cannot say that this is definitely false. It could be either true or it could be either false, right? So this option is incorrect. We cannot for sure say that this is a false statement. This could also be true. So option D is incorrect. So now let's talk about option B and C. So option B is saying that it uses preemptive scheduling, and option C is it uses non-preemptive scheduling. So basically for this operating system, given the process state transition diagram, we have to figure out whether the scheduling policy used by this operating system is preemptive or non-preemptive. So first of all, let's quickly recall what is CPU scheduling. So out of all the processes that are there in the system, the operating system has to figure out to which process should the control of the CPU be assigned. So this activity of taking this decision, this task of taking this decision comes under CPU scheduling. And also once this decision has been taken, then assigning the control of the CPU to a particular process, that also comes under the task of CPU scheduling. So CPU scheduling is basically the operating system figuring out which process should be assigned the control of the CPU, and then dispatching the CPU to that particular process. So this was about CPU scheduling, and now there can be two types of CPU scheduling. Either it can be preemptive or it can be non-preemptive. So what is a preemptive CPU scheduling policy? Basically, if the operating system is allowed to forcefully take the control of the CPU from a running process, then such an operating system is said to follow preemptive scheduling policy. And if the reverse is true, that is, if the operating system is not allowed to take the control of the CPU forcefully from the running process, then such a scheduling policy is non-preemptive in nature. Okay. So basically, in a non-preemptive scheduling policy, the control of the CPU cannot be forcefully taken away. It has to be voluntarily relinquished by the running process. Only when the running process decides to give up the control of the CPU, it could be because the process is like getting terminated, or it could be because the process is going to a block state for some reason. Only it when it voluntarily gives up the control of the CPU, then only the control of the CPU can be taken away from the running process in a non-preemptive scheduling policy. In a preemptive scheduling policy, the operating system can forcefully take the control. So now let's focus on this process state transition diagram. Here, if you see, if a process, so let's focus on this transition. Once the process goes from ready to running state, right? Now, once it goes to running state, there are only two options. That is, it will exit this running state. First, if it is getting terminated, then only it will leave this running state. And the other option is that if the process is going from running to block state, if the process is blocked for some reason, let's say it is waiting for some IO operation, or it is waiting for some research, then only it will leave the running state. And only when it leaves the running state, then we can get the control of the CPU. So as you can see, there is no transition from running to ready, right? So this is a non-preemptive scheduler. Only when the process voluntarily is deciding to give up the control, either by terminating or going to block state, then only we can get the control of the CPU from the running process. So if you recall the process state transition diagram that we studied, there is another transition from running to ready state. So this transition, if this transition is present, then you can say that this scheduling policy is preemptive in nature, because when this transition is happening, here the process is, this running process is being descheduled. That is, the control of the CPU is being taken away from the process. So this transition is very important. If you see that this transition is present in a transition diagram, then you can definitely say that the scheduling policy is preemptive in nature. But since in our case this transition is missing, we can say that this is a non-preemptive scheduler. So this statement, that is, it uses preemptive scheduling, this is a false statement. So this option B is the correct answer. And option C, it says that it uses non-preemptive scheduling. So this is a true statement. So since the question is focusing on the false part, so this is again, this option is again false. Okay. So the correct answer is option B, that this this statement is false. It uses preemptive scheduling. This is not true, right? This operating system is based on a non-preemptive scheduler. So guys, this was it for this video. Thank you very much for watching, and I will see you in the next video. Thank you.